So guys, my metabolism and macros picture, and this is a cool way of kind of describing how everything works in the body, but I'm gonna have to explain what each thing is. So I'm gonna kind of zoom in, and this will be a bit shaky on the camera. So up here we have lean body mass, little cube here for lean body mass. Over here we have glycogen, we have these little stripy lines that are representing glycogen. Here we've got protein, carbohydrates, fats, body fat, and 1 kilo body fat is 770 calories. And over here we've got 50 grams, so it's wee line here, and that's 385 calories. Over here, we've got our RMR. This box here represents our RMR. This little dotted line saying comp here represents our compensation. So our RMR can actually go down and compensate if our activity goes too much. And this here represents our activity. So NEAT is your non-exercise activity thermogenesis, and your EAT is exercise activity thermogenesis. So this is all activity. And the line is like this because if your exercise increases, your NEAT will decrease. And if you don't really do any exercise, your NEAT may increase. And this is may, and this is really individual for everyone. And also if your exercise increases, you can compensate on your RMR. Your RMR can actually drop. So the calories in, calories out can be really difficult to understand because sometimes you do more exercise, you think you burn more calories, but then your resting metabolic rate just compensates that exercise out. We'll go into more detail, but that is explaining everything that's on this board. One other piece here is food that we eat. So we've got protein, fats, and carbs. That's in food. You have a thermal effect of food. So some of these foods, like say protein, 25% of protein is broken up through its own digestion, and that's called the thermal effect of food. Basically, whole foods have a higher thermal effect of food, and processed foods have a lower thermal effect of food. And then these split off into three little branches that go here to your protein, carbs, and fats. Okay, so quick overview. You eat food, there are protein, fats, and carbs, whether you track them or not, they are. You get the thermal effect of food, they break down into their macronutrients, your protein, your carbs, and your fats, and then they go over here into your metabolism, which is your RMR and your activity, and then you exhale this as breath as CO2 that can be measured. So the carbon that you eat here in food goes through the system, broken down into digestion, and comes out as breath, and also comes out as movement and metabolic function like your brain, your liver, etc., etc., etc. So when people talk about calories in, calories out, what they really mean is carbon from the food going into the system and breathing out that carbon as CO2 that then rejoins the cycle, becomes plants, and we eat those again. And those plants capture energy from the sun, which is the actual energy in the calorie. That's what the calorie is measuring. It's measuring that energy. So this is the cycle. So when we talk about calories, we're talking about the energy in food that's connected to carbon. So we got our food up here, it's broken down into the body, we lose some of that energy in the thermal effect of food, it goes to its various compartments, the protein, fats, and carbs, it moves over here into our metabolism, it can become movement, it can become heartbeats, it can become all kinds of things, but the waste product is CO2 that we breathe out. We also pee out some water. It's 84% carbon dioxide and 16% water. That CO2 then moves up here and becomes a lovely tree, becomes some apples, it becomes grass that then the cow eats. And when that carbon comes about, sunlight comes down, photosynthesis, gets that energy from the sun trapped with the carbon, and then that eventually becomes our food. And that energy from the sun is the energy that we measure in calories. So calories are a thing, but I'm gonna show you in this video why macros are maybe more important or why calories are still important. So in order to lose weight, you've got to exhale more carbon than you ingest. And there's ways and means to do that. So protein need is dictated by lean body mass. Carbohydrate need is dictated by how much glycogen you have stored, but it's really more dictated by how much exercise you're doing. That will dictate what carbohydrate need is. So carbohydrate is the most flexible macronutrient because if you're doing lots of exercise, you can have more carbohydrates because you need it to power this higher intensity workouts. And I would also include that NEAT is your non-activity thermogenesis, but I really change this to low intensity and high intensity movement, or fat dominant movement or carbohydrate dominant work. So your carbohydrate dominant work or your chosen exercise will dictate your carbohydrate need. And then the rest of your macros can be made up of fat, depending if you're wanting to maintain or lose body fat. And you can lose each of these in little increments going along. So despite the fact it's about energy in, energy out, or carbons in, carbons out, depending if you meet your lean body mass requirements, your glycogen requirements, those things will dictate how much hunger you have. And the more hunger and more your appetite is stimulated, the more likely you are to eat. So by meeting your lean body mass requirements and your carbohydrate requirements, you'll have more control over your hunger. And also, if you're eating processed food versus unprocessed food, the unprocessed food has a higher thermal effect, which takes longer to digest, which will kind of keep your appetite regulated and your satiety high. If you're meeting your lean body mass requirements of your recommended grams of protein, split into 3 chunks throughout the day. That way you're getting a constant feed of amino acids. That will regulate your hunger more than anything else that you do. So to work out how many calories you need to know how much exercise you're doing, how much NEAT you're doing, and what your MAR is. And if you add these together, that will give you your total daily energy expenditure. To the board, sorry about shaky camera, just trying to hold it with one hand. So we've got our protein and we know what our protein needs are. Insulin resistance can affect this, and your protein needs might actually go down the more insulin resistant you are. The good news is exercise will improve your lean body mass and improve your insulin resistance, and as well as your glycogen storage. So as I discussed before, protein becomes carbohydrates. So then we've got this carbohydrates and fat thing. So carbohydrates do fuel this RMR aspect a little bit, but are mostly used for your EAT, your activity thermogenesis, or your exercise activity thermogenesis. And also, the more high intensity, the more carbohydrates you use. And we have a big hole here for carbohydrate usage. So depending on how good you are at burning fuel in exercise, your low intensity might be down here if you're poor, or your low intensity might be up here if you're a bit better. When we get over to fat, some of us have a really poor fat burning potential. And this is gonna slow down overall fat loss. It's gonna cause a bit of a backlog. It's gonna cause you to be hungry. It's gonna cause you to eat carbohydrates. And remember, carbohydrates generally don't come alone. Something like a cake is more fat than carbohydrates, even though we call it a carbohydrate most of the time when we're looking at it. This is why tracking macros is so important, because you can see what you're actually getting in. And we have a small hole of fat. So we can only burn, say, 100 calories an hour of fat. That's not very good. We wanna make this hole bigger so we can burn more fat per hour as our fuel source. And we can do this by making our low intensity exercise more efficient in this zone 2. So we can go from, say, 100 calories per hour to 150 to 200, or maybe even beyond that point, which will then be a lot more beneficial when you're going through your daily life. And I guarantee your hunger and cravings will be a lot more under control. So this next little slide that I'm going to pop up here shows the difference between elite, recreational, and type 2 diabetic group that all have a different fat burning potential. So the elite group there are like 0.7 grams of fat per minute, and the type 2 diabetics are like 0.2 grams per minute. If you need help with any of this, working out your total daily energy expenditure or what your actual macro breakdown is, feel free to give me a shout. I have a link in the description box for a type form for you to fill out, and I'll get back to you if you're interested in online coaching.